thousands of years. Good afternoon, everybody. Welcome to class today. Thank you for joining me. Whether you're watching live or you're watching the recording, I appreciate you watching. Thank you for joining me today for this week's live class for CIS Sp24 Java programming. And this week we're talking about creating new methods. Up until this point, we've done all of our work in one singular method, right, which is the main method. We still need that main method going forward because, as we'll talk about, everything that we run has to be ran through that main method, whether it is in the main method or in some secondary method. And we're going to be talking about just void methods for this particular module. We'll look at value methods in a future module and make a distinction between what these two different types of methods are. But for today, we're just going to be focusing on creating new void methods to add a little bit of flexibility to our programs. So what we're used to is using one method inside of one class, right? And that gets us to basically what we're used to doing all the time, right? So if we look at a replit here, this is our standard Java replit. You know what? I think, yep, I made it public. So we'll delete these comments out of it. And this is what we're used to seeing, right? We're used to seeing one particular class. This class is called main. And one method inside of main. And previously in these live classes, we've talked about this main method, and we said we need this main method here. Right? We need this public static void method. We don't touch this main method. Whereas this main here is a little bit different. Right, our public class main is different than our public static void main. Our public static void main, that's our main method. All of our other methods have to be run out of this method. Whereas our public class main is our class for this file. And we say that this name here, main, has to match the name of our file, which is here, main.java, right? So that first part before the .java is uppercase M main. And we have this main in this class. So what we're going to be looking at here primarily is this public static void main. And we might even look at maybe doing another class in a different file. Might be something that's kind of interesting to do today as a bit of an example. Right, but this is how we're used to dealing with it. But with what we're working with in this module, we won't have to deal with things in that way anymore. Because with the way that we're going to be dealing with things like this from now on is we can write different modules to do different things. So what I might want to do is take my program and segment it out. Right? This is one of the big reasons why we do this, right? We can take our program, we can segment it up, we can have different small pieces, do different things. And we can we do what we call composition, which means that if we take one activity that our program does and isolate it to a particular function or a particular method, as we would call them in Java. A method's really just another name for a function if you're familiar with some other programming languages. Then we can compose one action to one function or one method and let that be it, right? So that when we go to test our program. We find if there's something wrong. If it's something wrong that's with a particular output, we can relate that particular output with a particular function and more quickly and easily isolate the issues. Right? So just to look at this in a bit of a different way, right? We see, exactly what we just saw there. Class main, right? Public static void main. We say that this class main is different than this void main. This void main is going to be in every program where we need to run something. This class main or public class main can change based on the name of the file. And then whatever we want to run, we run it inside of our main, which is our typical example with our hello world. And it's also the way that we've been writing our programs for the last several modules. So how this works basically is we have a main method that takes precedence in our program. That's why we need that void main, right? It takes precedence in our program. Everything that we run in our program needs to be run through this main method. So even when I have other methods that I write in my program, I will need to refer to them inside of that main method in order for them to work. Right? Because the main method is what what runs as the compiler interprets and compiles our programs. So how do we add new methods? Well, we create new methods in a really similar way to that main method that we're used to seeing, right? Especially for the time being. Public static void main. Public being the scope of the function. Static being the type of data for the function. It can be a static function or a non-static function. Void being the type of function that it is. And then main being the name of the function. So for now, we're only going to be learning about void methods. And in a void method does not return. When we get to value methods, we'll talk about the difference between value methods and void methods. Value methods return, whereas void methods do everything that needs to be done inside of that function. Method names, when we see a method in our program, method names will usually begin with a lowercase letter and use camel case. That means, every time we get to a new word, we get to we put a uppercase letter at the start of our new word. That way we can kind of read our method names a little bit easier. So when we run the new method by adding a reference, or I tell you what, I'm getting a little bit ahead of myself here. So let's write a new method, and then let's look at running a new method. Right? I'm getting a little bit ahead of myself here. So let's take a step back and let's write a new method. So let's say I'm going to want to still do a hello world, right? I'm going to want to still do a system.out.println hello world, but I'm going to want to put it in another method. All right, so let's take it out of here. So what I want to do is I want to create a new method. When we see these curly braces here, these curly braces define our methods. Right, so I have this open curly brace here and this closing curly brace here on line 5. These are the two curly braces that delineate my void main method here. And then when I see this curly brace here on line 2, the opening curly brace, and the closing curly brace here on line 6, those are my opening and closing curly braces for my class, the class of main in this case. So all of the methods belong to the class. So all of the new methods that we write in this file will go between what I have in green right now as the opening and closing curly braces for this class. Right, so I'm going to write a new method here. I'm going to go to that closing curly brace there on line 5 and just hit enter. Right, so you can see that now I'm between the closing curly brace of the void method, the void main method, and the closing curly brace of the class. And I'm going to just give myself a little bit of room to work there by adding a couple more line breaks and add my my method instance here. So this is going to be a public static void method that I'm going to call say hello. And then in parentheses here, I'm going to add nothing for the time being, right? Like we might want to add something here, and we might go back and add something here in just a moment, right? This is where we put what we call parameters. Parameters could also be called arguments. You could hear people use those terms interchangeably. But when I talk about parameters and arguments, basically what I'm talking about there is I like to relate it to the pneumatic tube at the bank, right? If you've ever been to the bank and you've gone through the drive-through of the bank, you see that tube, right? That takes your card or your check or whatever type of business that you need to do in the bank, takes it from you and it sucks it into the bank. That way the bank teller can do what they need to do with it, right? And so that's what we're talking about here really when we're talking about a parameter. Is we're talking about something that gives us the ability to take some data into another function and do something with it. Right, so I'm going to make sure I have a set of curly braces here for this function. Right now, I'm going to leave those parameters blank because I don't need to bring anything in the function. All I'm going to do is just system.out.println hello world, like so. So now I'm not saying hello world in that main function. I'm saying hello world in my say hello function here. And so if I try to run this, nothing will happen. All right, we see we get nothing on our output. And that's because, as we mentioned, everything has to run through this public static void main method here, our main method. Everything has to run through there. So it's not enough that I just create a function or create a method. I also have to do what we call invoke that method, right? And when I invoke that method, all I'm doing is I'm just putting a little reference to the name of my function inside of this main method or inside of some other function, right? I can chain functions together and I can do all sorts of stuff with my functions as long as I'm making sure I invoke it in the right place. So in this case, all I'd have to put here is a reference to say hello. And there we have it. Right? Now I have this reference here, say hello. So now it'll know, okay, when I see this, I know to run this function, and I can say hello. So when we run that function, we get hello world in our output. Sorry, all, just a moment. So another thing that I can do here is that I can take advantage of this parameter. And a parameter is just basically a variable, but it's a variable that's specific for this function. So what I might want to do is I might want to say, oh, well, I want to be able to take in a string that is a message. Right, and so I will kind of create an instance of a string variable here with the name message, right? Just kind of like we would do previously. If we were doing this in the main method, right, we'd create some string data type with the variable name message. And then later on, we might say message equals new string with a value of whatever. Right, but this name message here, MSG, is specific for this function. Right, so if I use MSG here and I use MSG here, those are two different messages. Those are two different names of message. So what I suggest to you is to try to use something different. Right, because if you use the same thing over and over again, it'd be a little more difficult to distinguish because those are different things. But now within this say hello method, I can use MSG however I want to use it. So I can just put it in here as the output for this print line. So then I could do something like this, right? Like I could import java.util.scanner. Right, I could go into my main method and I could create a new instance of scanner. So I could say scanner in equals new scanner on system.in. And that string and then so I can have some sort of string variable. We can call this one string m, let's say, equals a new string that is in.next line. Now the other thing that we would want to do here, right, is the thing that we were talking about last week when we were talking about getting inputs from our user, and that's just prompting them to enter something. So we can system.out.println or system.out.print, even if we wanted to keep that on the same line as what our user enters in. Enter a message. Like so. So now what we can expect to see when we run this is our user will, or we're actually missing a step here, right? Because I actually deleted my invocation. I deleted where I invoked the function. So now all I need to do is I need to invoke the function, right, which is say hello. And in the place of message here, I need to put the message that I want to send, which in this case is our string variable m. So I can just pop that in there like so. So now I have say hello with the string variable m. So what I can expect now is when I run this, it will ask me to enter a message. I will enter a message. That message that I enter will be passed through our pneumatic tube, right, through our parameter, to our say hello variable, which will turn it from m to msg, and then it'll get printed out in the system.out.println message here. So if we run this now, we're going to get our message here to enter a message. I'm going to say something like, how are you? And we get echoed back out, how are you, right? It's basically the exact same way that we were doing things in the last module when it comes to getting text from a user. Just now we're taking that text and pushing it somewhere else for it to be used, right? We're pushing it to this other function. And I could even do this with other files. All right, so if I wanted to create a new file here, I could create a new file and call it something like say something.java. And I want to be able to put it in that folder with the main.java. So they're on the same, so they're in the same folder. Right, so now I have a different class here that I can write. Since it's in the same folder, I can import it into main.java. And so what I want to be able to do is I want to be able to say main.java, our public class main extends say something, right? And that's the name of our other file. So if we go into this other file, we can create a public class say something. And inside of here, since this is not where I'm wanting to run my program, I want to run my program in my main.java. I can put a function in here that is public static void here's something, here something. And I can just type in what I want to say here. Right, so I can say something like here system.out.println here is something. So now I'm able to use this function that's in another file in main.java here, which is pretty cool. Now what I might want to do here is use this as an object, but I don't necessarily have to, right? So let's just play around with this and let's try to call this function in main.java now. All right, so if I just take and do some commenting out here, comment out everything I don't need. I know this extends say something, so I can call say something, which is the name of that other class, dot here something. And so now it knows that I'm referencing the say something file. This file is extended by class main, here's something. So now it's going to know when I run this that it can go to this other file, grab this, and do this instead. So let's run that. And there we see, here is something, right? Which is pretty cool. I can even take a parameter and pass it across, right? So now that we're kind of ready to see that, I can take that and uncomment that, take that, uncomment that. We can enter our message and we can take our string, and instead of passing it to this say hello function that's in the same file, we can pass it to our say something that is in our next file. Now we see a little bit of an issue here, right? When I put that M in there, we've got a problem, right? And the first thing that is a problem is that, well, there's no parameter over here, right? We need a parameter over here that's going to be able to accept this string value. So I'm going to put string MSG here. And it could be string whatever, right? That's just like a variable name. So then instead of our print line here, we're going to put our message here. Now let's see if that has changed our squiggle here in main.java, and it has. Right? So now that we see that say something dot here something, M is going to be what we get from the user. So now we have this coming from this file. We pass it off to an entirely different file, That's an entirely different place in our program. We can run it. We get the message of enter a message. I can put something like I've said something here. And we get that echoed back out. Right, so being able to use multiple methods not only gives us the ability to do what we call composing within a particular file, right, with multiple methods in a file, we could actually do composition across multiple different files. And this is also one of the points where I could do something pretty cool with like objects and stuff like that. Right? For instance, if I wanted to actually do this object-oriented, not only would I have a public class, but I would have a public item in my public class. Right? So I would have, say, and it would have to match the name of my class. So I would have something like public, say something. And in this case, I could create something like, and I would want a parameter here. And so I would have like a string of message here. So now what this helps me do is this helps me create an object. And an object is another location in memory where something's being stored. And what that allows me to do is it allows me to do multiple things with multiple bits of memory. And I can implement things across multiple bits of memory easier. It's going to be more efficient. It's going to be more effective. And it's just going to be easier. Right? And so in this public say something here, I'm going to want to define this term message as what it is. Right? And so I can say, well, in relation to this class, this dot message equals message. And so now this other string message here, I don't need it anymore. Also, what I would want to do here is I would want to create a public variable at the class level, which I believe we were talking about that last time when we were talking about creating scanner at the class level. So I would need like a public string of message at the class level. And so now when we bring this in, right, we're going to do more than just sort of bring it in. We're going to create an object of this thing. Which is going to be pretty neat. And also, I think right here, this would be this dot message. Or maybe not. Might be getting a little bit ahead of myself. We might have to do a little bit of editing here. But that's part of it, right? Oh, we're making a static reference to a non-static field. So to solve that, I could take out the word static here. Right, would be the easiest thing to do since we are not in the main Java class. The other way to handle that would be to create an object of the method inside of here. So something like say something s equals new, say something. And then I can do s dot. Now it is giving me that the constructor, say something is undefined. See if I can remember what I'm doing here. That should be at the class level. What am I forgetting here? I'm forgetting something. I'm forgetting something. What do I have to do? I might have to do this. And then it's this dot message. Or no, it would be s dot message. No. What am I doing? Because I have public say something, but it needs the. It needs that? Yes, it needs that. It needs the empty string. Or it needs something there, right? Because we have this parameter here, string message. And so we need something to take that parameter's place in the call of our class here. Right, as we're making this object. So now we're looking at s.message, although I do think that's going to break it. So I think what I want here is message. And then string message here. I think so. I believe so. I think that gets us to where we want to be. Right, I wasn't necessarily planning on doing multiple files today. I don't normally do it at this point in time, so I don't have my notes here in front of me for this particular structure. So I am kind of winging some of this, but you know, we'll figure it out. We'll get there. Right, so now what I would want to do here, instead of doing this, I would want to create an object here. So I would want to do something like say something, and I'll put that back and comment it out. And I would say something like, say something equals new, say something with the value m in here, right? So that's going to create a new instance in memory of something that has the value of whatever is passed in. Then I need to call the function, right? So I can have something dot message, or I could have something dot here's something. Although I think all I would need to do here is something.message. And I would want to put that in system.out.println something.message. Right, so now when I print that out, that's going to print out whatever this is, right? So it's going to echo it back out. I'm going to run it. Whoops. Well, I think since I did that, I would want to get rid of that now. Yep. I forgot that when I make it into something that is instantiable as an object, I no longer have to worry about extending the class with the other file. So that is another way to do it. We have this message there. We can say something like, here's a thing, and then we get, here's a thing, right? And so we get that coming out. Here's a thing. Here's a thing. Or we could call something dot the function. Here's something. Here's something with the value of something dot message. Telling me it should be accessed in a static way. But this should work, I believe, just as is. Here's a message, and we get here's a message echoed back out, right? And that's because we have this public static void here. If we wanted to, we could remove the static here. And I believe that would get rid of our yellow squiggle here, which it has, because now we're addressing this in a non-static way, and the function is non-static. So we can enter our message, and here is our message. And we get, here is our message back. Right, which is pretty cool, right? And this is a little bit more advanced, right? It's a little bit different from kind of the stuff the module talks about, which is why I want to demonstrate it here, just because it is a little bit different. And so now we're not only able to access functions, different functions that are in our own program, we're able to access different functions that are in different files, which gives us a whole lot more flexibility. Right? Different functions in different files give us a lot more flexibility. And so from here, we could start talking about other stuff. All right, and I think a lot of this we've already talked about here, so we can just kind of flow right through some of this stuff. We talked about invoking methods. Methods can also be invoked within other methods, right? So I don't just have to invoke a method within main. I can invoke it in a different method. As long as some method in the chain gets invoked in main, then we are fine. Right? But it still won't execute until the containing method is invoked in main. We'll do a little example here in a minute, and we'll look at that. We also have recursive methods. We're going to put a pin in recursive methods for right now. Recursive methods give us the ability to invoke a method within itself. So this causes the method to enter a loop, right? And just do a thing over and over and over and over and over again. Which is pretty cool, right? We'll do more with recursion in the future. right? It's a big enough topic to kind of have a module to itself, or mostly to itself. And we will need to talk more about conditionals before we can get to the concept of recursion in any more depth. So we're going to pin the idea of recursion and come back to it later. We can add arguments to created methods, which we've already talked about. Arguments or parameters, being able to send data through our pneumatic tube from one function to another function. Right, and we've seen our declaring objects syntax here, right? So we see this example here. We have string x and string y. We can bring them both in to a singular function or singular method and use and concatenate them in there to do whatever we want to with them, right? And so we see here we're bringing two parameters in, or two arguments in, right? We can see that, you know, the way we pass the data into these is we just put it in the same order as we get it on the output. Right? So if we compare these two files together, we see string x, string y. In this case, our high variable would be string x, since it is first. Our string y here would be our w variable, since it is second. Then we could use that, pass that, do all the data that we want to work with. And have a great time with it. So, let's do a little problem here. I've got our usual coding challenge that I would do with this module, which is about getting a heart rate, right? And I usually do it around this time of year because of Valentine's Day, so we do heart rate and all that kind of stuff. But I think I want to do something just a little bit different. Let's do some sort of math problem here. Let's do maybe volume of a pyramid. Right, so length, width, height, over 3. So length times width times height over 3 gives us the volume of a pyramid for a right rectangular pyramid. So I think something that I want to do here is I actually want to do this in this same replit and just do it in another file. Right, so what I'm going to do here is I'm going to comment all of this stuff out. And I'm going to do most of my stuff in another method here in main and in another file, right? So we'll make another method. This will be a public static void method called, let's call it get volume. And in here, we will put our invocation for our scanner. Right, so we'll say scanner in equals new scanner on system.in. Right, so now I need 3 values here, and these should all probably be double values for the purpose of precision. Right, so we take system.out.print, enter base length, And then we say BL or double BL equals n.next double. System.out.print enter base width, and then double BW equals n.next double. Right? This is all just sort of a reminder of the things that we were doing in the last module with scanner. And then finally, one more here. That's going to be our pyramid height. So system.out.print enter pyramid height double PH equals n.next double. Right, and we could also n.close from here. So now I want to take these values and pass them to another function in another file. Right, so I'm going to create a new file here. I'm going to make sure it's in the same folder as my main.java and subsequently my saysomething.java. And this will be called pyramidvol.java. Right, so now in pyramidvol.java, I can public class pyramidvol. Right, so I've established my class here. Remember that we need to make sure the name is the same as it would be before the .java here in our file name. So uppercase P, uppercase V, uppercase P, uppercase V. Like in our say something. Right, we have these objects put into here. We can do that here as well, right? And just call the object if we want to. So what we would want to do here is to instantiate 3 new variables, right? A double length, a double width, and a double height. We'll create a public pyramidvol to be our object, right? And that's going to take length, width, and height. Inside of there, we're just going to this dot everything. So we're going to say this dot length equals length. This dot width equals width. And this dot height equals height. And I would also need to declare all these as doubles as well, right? So that's a double. That's a double. And that is a double. Right, because technically when we look at this, this double is this variable, and this length, we'll do pink. This length here is length here. Right, so technically I could do something like this instead, and I could say double L, double W, double height, or double H, and then change these to this dot L, this dot W, this dot. Or I might have those backwards. Or no, I might not need, I don't need this dot. I can just do them that way. When they're not the same name, there's no confusion with different names, so I don't have to use this dot. And so now I can kind of do something like I've done here and create our function. So in this case, we're going to create a public void find volume. In this case, we need a double L, double L, double W, and double H. Right, and remember that L, W, and H here is different than L, W, and H here. But I know what those are now, right? So I need to just get me a new, or sorry, pyramid vol P equals new pyramid vol L, W, H. Right, so now I have P.L, P.W, and P.H that I can reference. So I can just say pyramid volume equals P.L times P.W times P.H divided by 3. Or what am I missing? Oh, I know what I'm missing. This should be a double pyramid ball for one thing, and then I can get rid of it, I believe. And I think if I wanted to, I could make this P dot pyramid volume and then do the P's here. Right, P dot, or maybe not, right? We don't have to worry about that. We're fine. So now I can system.out.print F. We talked about our format string last time, right? So we can say something like so that way we can kind of take that, and so it's like point to F, right? So we can say something like volume of the pyramid is percent symbol, point to F, comma, pyramid volume. And there we have our output. And now I should be able to instantiate a new instance of our object here. So we could probably take this from here, move it over here, because that's where we're going to want that. In this case, we don't have L, W, and H. We have BL, BW, and pH. And so then when we run P dot find volume BL BW BH, or pH rather, we end up with our solution. Right now, if we run this as is, nothing will happen. Right, we actually do get an error here, and it is because I forgot to put that colon inside of there. I put it outside of my quote. A little mistake that people, mistakes are made all the time. Now if we run it, we'll see nothing happens. Right, and that's because this function, this get volume function, has not been called in our main function. Right, so this is one of those instances where we are chaining together two different functions. And if you don't want to use a different file, you don't have to worry about all this object stuff, right? Like, let me just tell you that straight up right now. You can just chain them together kind of the way that it shows you in the module. But from here, right, what I can do is I can just reference get volume. And so now that I have that reference to get volume in my main method, that reference is going to run this function, which is in turn going to run this stuff over here in this file, which is going to get me the volume of my pyramid. So if I run this, enter base length, let's say it is, I don't know, let's go with 14. Enter base width, let's say that is 12. And enter pyramid height. Let's say that is 20. And so we get 1,120 there. And if we use Google to help us out with that, like we are, or like we should be doing, right? We see we can use Google right rectangular pyramid solver here. 14, 12, and 20 gives us 1,120 as a volume. So it'd be 1,120 units cubed, which is exactly what we get. So now we pretty much know that we can trust this, so we can start to enter some more fancy numbers. And we can assume that what we get is correct, because we know that it worked on something that we tested it against that we know would work, right? So we entered 12.5. We entered 13.29. And we entered 20.127. And I'm checking my work here against the Google solver here. And in the Google solver, we see that it is 1,114.53263, but they also round it to 2 decimal places like we did here with our printf. So we get 1,114.53, which mirrors our answer, which means we have a functional program here that allows us to get the volume of a right rectangular pyramid. Something else that we might want to do here is just maybe put a little print statement in here that says something like system.out.println volume of a right rectangular pyramid. Just so we can have sort of a just message to let our user know what they're looking at here while they're running our program. Volume of a right rectangular pyramid. And we can just enter numbers in. And trust our output. So that gets us to our hour. That is all that I have for you for today. So we'll go ahead and wrap up here. If anybody has any questions, please ask them. You can ask them in chat. You can ask them via email or via Teams. If you're watching the recording and you get to a question, please send me an email or a Teams message and we can answer it to the best of our ability. That's all that I have for you for today. Thank you for watching. We'll see you next time.